What you see in front of you now is a KenKen, and it's called a 4x4 KenKen because it has 4 rows and 4 columns. What I normally suggest that people do when they're starting out with KenKen is to write the numbers 1 through 4, if you're doing a 4x4, on the top side or bottom. And that way you can look at the numbers and realize the relationships between them, and it just makes the whole thing a little bit easier. For those of you new to KenKen, the first 2 rules are the same as Sudoku. In other words, if you look at this first row right here, as in any row, all 4 numbers have to show up, no repeats. And in each one of the columns, such as this one here, all 4 numbers have to show up with no repeats. So that's exactly the same as Sudoku. The third item, though, the third rule is where it gets different. Take a look at this area over here where you have 2 squares and they form what they call a cage, and you notice that you have a very large thick line around here. Those 2 numbers, according to this scenario up here, have to add up to a total of 4. These 2 squares right here, those 2 numbers, have to have a difference of 2. So for instance, it could be the numbers 2 and 4, or it could be the numbers 3 and 1. But they can be also in either order. You don't have to have the larger number on the top. So that's basically what these symbols mean right here. This one, for instance, 2 numbers are going to multiply to give you 6. So let's go ahead and solve this KenKen and learn some techniques as we go. First thing you want to look for is free ones. And free squares are things like this. That's a singleton, and the clue says 3. You've only got one choice. And if you try to fill in the rest of this row here, you notice that you've got a couple of problems. For instance, these 2 squares here have to divide to give you an answer of 2. So it could be 2 and 1, or it could be 4 and 2. But you don't know which combination. Not only that, you don't know in which order. So we're going to leave that for a while. We don't have enough information. Let's go to another cage over here. These 2 numbers have to add up to 4. And they can't both be 2s because that'd be a repeat. So it has to be either 1 and 3 or 3 and 1. And what I usually suggest people to do is that right along this borderline here, put the 2 numbers that are going to have to appear in the 2 squares. The only question is which goes where. And in our situation here, the number 1 has to go on the bottom because you can't have a 3 because that would duplicate the 3 on the other side. So what that means then is the 3 has to go up here. And then if we look at this column, we've got 1, 3, so therefore these 2 numbers here must be 2 and 4. And if you want to put a reminder here, you can put a small 2 and a small 4 here. We're just not sure at this point where they're going to go. If we look at this cage right in here, we said we want 2 numbers that have a difference of 3. And this is where this scenario up here really helps. If you want numbers to have a difference of 4, it's kind of like looking at a number line. You can see that those 2 digits right there, those 2 numbers, are separated by 3. So if we come back down here, we can write a number 1 in here, and we can write a number 4 in here, indicating that these 2 squares have to have those in common. Well, we're getting a lot of choices here, but not a lot of answers. So let's see if we can go a little further here. Let's go back down to here. And we know that these 2 numbers have to be 2 and 4. So I'm just going to write the 2 here and the 4 here. And now let's take a look at this box right over here. And if we look vertically up here, we see that there's a 1 and a 4 here, which means you cannot have another 4. Ergo, which is Latin for therefore, means that must be 2, which means the 4 has to go over here. And now we're making some real good progress. We already have 1 row completely done. So that looks awesome. That looks very cool. So let's try back over here. In this column we have a 2, a 1, and a 4, which means the only remaining number must be a 3. So that has to go up here, which means, of course, that this has to be a 2 because the product of these 2, according to our code here, has to be 6. Continue over to the left here, and we realize that the 2 choices we have are 2 and 4. Therefore, or with Latin, ergo, that must be a 4, and this must be the 2. And moving to the right here, 4, 3, 2, this one must be 1. Has to be that way because you have to have all 4 digits and no repeats. which means that these two right here must be the digits 2 and 4 in some order. And we're not sure exactly which one it's going to go, so we'll just see what happens. Well, let's come back over here and maybe we can make some progress on here. We need a 1 and a 3. Well, it turns out that you can't have the 3 here because that would duplicate the 3 over here. So the 3 we're missing has to go up here, which also brings another one of the puzzle tricks here, if you want to think of it that way. Take a look at all 4 3s, because that's the fourth 3 that came in there. And all 4 3s are in different rows and in different columns. So this is working out very well. Let's see if we can use that trick one more time. And what I'd like you to do is to look at the 2s. You have a 2 here, here, and here. So where does the last 2 have to go? Find a row and a column that do not have a 2. And if you look carefully, you'll find out that that last 2 has to go here, which means that this has to be either a 1 or a 4, because it has to divide to give you a 2, and by process of elimination that has to be 1, which means that this one has to be 4, that one has to be 1, and the only remaining possibility is this must be 4. And you can take another quick look over here and make sure that everything is correct, and indeed it is. So we've now solved our first 4x4 KenKen. Congratulations.